Yeah. See some guys in the back still getting coffee. After 2 days of E2E, you need coffee in the morning. So it's great to see you guys here, especially Neil, because I saw some Twitter messages from a couple of hours ago. So we're happy that you're here. Who of you were in the Netherlands with the Citrix user group and have seen the presentation before? Okay, a lot of the same stuff is in here, but we do have some new stuff in the end. So please stay seated, don't get bored, we'll get there.
Yeah, we'll do just a quick presentation. I'm Julian. I'm a consultant in France, and I think my team will win this year, maybe. We're going to try to do something fun today, present you some interesting results, really months of testing, so we can get started.
Yeah, so my name is Barry Schiffer. I think I know a lot of guys here. I'm from the Netherlands, and I don't think my team will win the World Cup this year. We have never won it, and we probably never will. So who do you think is going to win the World Cup? The UK?
No.
Brazil?
Bosnia.
Brazil?
No. Bosnia, yes,
I think Brazil. I mean, they have their home advantage. Not Spain, I hope again. So, just a quick story about how we met. I mean, it's actually Sean Bass' fault. Just, I mean, he was supposed to be here, I think, but he's not. Sean asked us a question about 2 years ago on different occasions, and he asked, why is it that when we were doing Citrix Secure Gateway, we would easily do over 1,500, 2,000 users on a Windows box. And now we have this specialized device, a NetScaler, a virtual NetScaler, and Citrix tells us we can only do 300 users on a NetScaler. So with all the new hardware we have, we are doing less users. That's weird. And we agreed, and we wrote we didn't know each other yet, and we wrote some articles about that, got into some fights with Citrix PMs, and then a year ago we got introduced in Paris, yeah, by Julian, or not by Julian, you're here, by Stefan, and we started working on what we're going to show you now. So it has taken over a year of discussing and testing and working on this. The agenda for today. We will give you a short introduction on what is SSL, why are we using it, and then we will show you all the tests we are running, why we are running it, and the results of that. And in the end we will also show you what we have learned, the things we were not expecting to happen during the test, which is actually, there's some cool stuff in there as well, and another argument with Citrix PMs, so that's always fun. Yeah, that's it. So, a short introduction into SSL. Why are we using SSL? Can anyone tell me why you would use SSL? No one? Is it that early?
Encrypts your data over the wire.
Okay, that's one.
The user can make sure that they're going to the right side and they're on the good side.
Exactly. So, the first one is to validate identity. So, if I would introduce myself, or I would ask you for your name, I know it's Wouter, but you would say my name is Wouter, and I would just accept that he is Wouter, and if he's not, and he's actually Robert, I don't care, I call him Robert, and that's okay. But what if someone tells me to give him money, and a lot of money, I would want to validate that he's Wouter. So I would ask him for a passport or a driver's license, just to show and trust that he's actually who he says he is. That's the same thing with SSL. We just hand out a certificate. The certificate, in the certificate is a domain name, and the certificate is handed out by a certificate authority. And if I trust that authority, I trust that the website is actually the website I'm going to. Especially handy when you're going to an online banking system and you're gonna handle some money. It's good to know that it's actually your bank. So the second part, as Neil said, is to secure your communication. So we use SSL to create a secure data channel and make sure that if we send the data, no one can read our data. That was the slide I was supposed to show you before what I said. So, just in short, what happens when we start an SSL session. The first part in an SSL session is the asymmetrical part, where we use the SSL certificate, mostly 2K now. A couple of years ago it was only 1K. And what we're going to do in the first step is just tell each other how are we going to secure our data channel. We give out some keys, so we both know a secure key, and the only one who knows the key is the server and the client. So all the packets will be encrypted. The server sends it, the client knows the key, so he can extract the packet, and then everything works. As long as you're not NSA, you're the only one reading that packet. So the performance question in SSL is just something about the first step. So the SSL handshake is where we would need performance. When we have done the SSL handshake, we will set up the channel on a symmetrical encryption level, which doesn't take that much performance. So it's only the new sessions that will take up a lot of performance. But if we look at SSL performance, what's happening? So everyone talks about when we move from 1K certificate to 2K certificate, that we would need 5 times the performance that we would need with 1K. And with 4K we would need 20 times the performance than we would need with 1K. But is that true? And does that hold up if we take a newer architecture CPU? So what happens to performance of SSL systems when we have a newer type of CPU? Or what happens if we introduce Cavium chips, which is specialized silicon to handle SSL traffic. The Cavium chips is actually what Citrix is using in their NetScaler and F5 is using in their big IT load balancers.
Yeah, absolutely. And this is where we come in to tell you a story, you know, I mean, on how and why do we do this presentation today. I mean, the whole thing started maybe 2 or 3 years ago, as Barry said. I was having a client needing around 2,500 CCUs on NetScaler and didn't want to buy hardware for it, right? So, well, I sticked up with the VPX and I was looking at it and I didn't see a reason why that thing couldn't perform right. And basically, the whole thing started there because we had a couple of months later when we got deployed, we had a production data saying that yeah, a VPX box can take 1,000 simultaneous ICA connections without any, it would be too much to say, with a very light performance hit, right? And in this case, we wanted to see how and what do we really need to seriously stress this VPX platform. And the whole thing started fairly easily, right? We deployed a VPX and then said, okay, let's use our workstations and try to test it, how far we can go. And then Barry came up with a magic figure that I want to do 1,000 SSL handshakes a second. I said, damn, how am I going to be able to do that? And then I took a JMeter and I asked all my colleagues, let's try to fire up and to see where it goes. And basically our machines were dying way before you could see any serious impact on a NetScaler. So, well, I took some serious magic silicon out there, a Dell R910 box with basically 40 CPU cores and 256 gigs of RAM. I put a JMeter on it, and basically I decided to press a button. And then our VPX platform is running on HP blades, G6 and G8. So we wanted to see how the G6 will perform against the G8, and of course we had an SDX platform, 11,000. Well, as you can see, a Xeon 5645, nothing really fancy compared to what we can see in a BL blade. And
yeah, so the G6 hardware is a Westmere architecture CPU, so it has a higher clock rate, but that's an older architectural CPU. And the G8 has the Sandy Bridge CPU, which has a lower clock speed, but is a newer architecture. So we're going to test if that makes any difference. And the SDX on right here is really a cool platform. I mean, these are like $100,000 list price boxes. We had them for a couple of weeks only.
yeah,
So we don't have them anymore. Trying to get our hands on some good stuff, but I mean, it's not out of pocket money.
yeah. I mean, it's very easy to get a €100,000 box and kind of enjoy it. So basically, we hit the GJ meter, right? Pushing 1,000 SSL connections a second. And this is what you will see on the backend, on the machine where the J meter is running, and that really explains why all our workstations were crashing. And taking a 48% CPU usage right on this type of box is a really serious CPU consumption. And with that, right, as you can see, the ramp-up period was 1 second, and we were looping this for 15 times.
Yeah.
So
JMeter is Apache JMeter. That's a HTTP test tool. So we can just fire up some scripts in there. We created fairly easy scripts. So the only thing we want to do is the SSL handshake. So we just connect and leave the connection open. No fancy stuff in doing stuff on the website. But this is really a cool tool if you want to do some load testing on, let's say, SharePoint or webmail or anything like that. You can create some simple scripts and just run through the website.
So basically, behind the JMeter, you had a load balanced VI servers, right? I mean, there was no point going further, right? Because once the SSL handshake is being established, there is no much to it to be done, right? So as Barry explained a couple of minutes ago, and then this is how it looks like when you hit a BL G6 blade, VPX running on top of it, and as you can see, this is a VPX 200 platform, Enterprise Edition, nothing fancy, one CPU packet engine, and of course, as with all NetScaler VPXs, there is one CPU dedicated for the packet, for management usage. So, as you can see, with approximately 1,000 HTTP requests a second, we're getting 85% CPU usage. So, what is really important to see here, I think next time we'll do videos, is that basically that hit, getting to 85% of CPU usage, this is not something that lasts for a very long time. The time necessary to establish those handshakes, right, and basically calculate all those really heavy stuff happening when you do establish an SSL connection, maybe lasts for a few seconds. So you would see the CPU going to 85%, and then 10 seconds later, once being processed, the CPU, with maintaining 1,000 connections, would go to 2 or 3%, not more, sorry. So this is, of course, the certificates used here were standard 2K certificates. This is very important to mention.
So this is only one screenshot. For every test, we reran the test 25 times and just took one of the screenshots that was most average for all of those 25 tests. So when you look at this, it's only one screenshot, but every test has been rerun at least 25 times.
Absolutely.
So just to make sure we are not having some kind of a weird test run.
Yeah, and what is really important to say here, that, I mean, basically we're running this on a relatively flat production platform, so there is no, I mean, the BL blades were not dedicated for the traffic. This is the reason why we were looping the test in order to avoid any kind of potential environmental impact we cannot exclude. But basically, looping those tests on multiple occasions, we're getting very, very similar results.
So remember, this is the Westmere test with the 2.9 gigahertz CPU. So now we go to the Sandy Bridge.
We wanted to see how the Sandy would perform, right? And honestly, I was kind of surprised to see that the Sandy Bridge, a lower clock processor, would basically top around 70% of CPU usage. The bandwidth was really similar, around 26 megs a second. We are still running on the 2K certificates, slightly higher number of HTTP requests a second, but basically this is what you get with the Sandy Bridge architecture. So we have a 17% improvement in SSL processing just by changing a generation of a CPU, which is just amazing. I mean, we can, and then we're coming to the real deal. We wanted to see how the SDX platform would perform, right? Basically, I was really satisfied with the results. I was saying to Barry, I don't think we can kill this stuff, because we were doing the tests, and I said, I mean, it's crazy. How can you justify a 100,000 euro box when you can run 1,000 SSL connections a second on a single VPX, right? And well, we said, okay, let's try with Cavium. Let's see what it goes. We imagine it will be close to zero, but okay, we should do it till the end. So as you can see, an SDX box. This is the SVM. I mean, view of it. Total 24 cores. Total SSL chips around 60, 3 SSL chips on 12, so you can basically choose how many SSL offloading processors you will allocate to your VM, and the memory you'll get to any of those. So this is what we got. There was an instance similarly sized to the VPX, so basically one packet engine, 2 SSL cards, 2 SSL chips allocated to it, 4 gigs of RAM, the same thing we had on the VPX platform.
And this is also a Sandy Bridge architecture, so it's comparable to the G8. There's a different clock speed, but for the it's the same architecture. Well, so here you go.
This is what you get from SDX, guys. 1,136. This is getting really high. The bandwidth is slightly lower. But I think this is not really relevant for the situation, because it is really hard with this box to take a screenshot at the right time, because basically it takes a fraction of a second where you will see this 4% hit on the processor, and it will go to zero, right? So I mean, this is the part where I was struggling the most to show you that there is a CPU move going from 0 to something, and that something was 420, and this was the maximum value, right? I wanted to get the highest value I can, because it was floating between 3 and 420, which was the maximum value. So this is what you get with the SDX, with the Cavium chips inside. I mean, absolutely amazing. All the SSL load is just taken by the card, and there is no impact on your box.
Yeah.
So we said, okay, let's see how it goes without a Cavium. And this was the real surprise, right? Because you can take the same machine, take those Cavium chips off of it, and then just rerun the test. So in this scenario, you have a NetScaler SDX CPU, right, treating and offloading basically the SSL. So I was amazed to see you'll get 5540 around maximum value every time we were looping for 25 times. So you'll get, I mean, these numbers were surprising. I would never think that it would outperform a VPX instance for, we are getting close to 30% margin in some cases. Absolutely unbelievable. And this is probably the first time I got surprised. And then I was looking for an explanation, and one of the explanations could be the SRIOV. You'll have the Xen server, because as you might know, the SDX platform is running on a stripped-off version of the Xen server. So basically here, I believe that the network cards running running basically on the back end or offloading had a lot of traffic, right? And this is why the CPU usage was lower compared to a VPX where we were running a standard E1000 NIC, and the vSphere version used was 5.1 if I remember correctly. So this is how the Xen would perform compared to a standard SX platform.
So especially for Claudio and Alex, Xen server outperforms VMware on this test. So just note that, please.
You are lying, we know that.
And that's the question comes on the latency. I mean, how is there any, while running those tests, was there any impact on the latency? So basically what we used is an insight center, right? So we're measuring the latency during the test, and it would get boring repeating this slide for 6 times. But we had approximately the same values, right? It's really no statistical error margin. The latencies were really flat during the test. There was no impact in any of ran tests on the VPX, on the SDX. There was no impact on the latency. So basically, all those things that at early times of VPX saying, yeah, well, you should be careful with it. Never go above, I don't know, 500 session. Otherwise, you'll get hammered by the latency. The user performance will be bad, etc., etc. Well, simply we couldn't prove it. I mean, the numbers really speak for themselves.
So we just put it up there, this up here, because all the Citrix PMs and all the so-called experts in the field are saying, yeah, but you're only measuring CPU and your latency will be higher and higher and higher. So we just made sure that we've got a picture up here.
Yeah, because they're saying, yeah, the higher CPU go, your latency will vary enormously, so your user will be kind of impacted on a day-to-day basis. And this is something I didn't see in production, right? Okay, I was never hitting not even as close as 1,000 connections a second. I was running 2,500 CCUs on the VPX. It was a finance industry, right? So very sensible users to a variation of user experience, and I never heard a single complaint saying, oh yeah, we have a performance problem. I mean, they did, but it was not NetScaler related, of course. So
then I got all Dutch, and I wanted to crash some stuff, and we said, well, we're now working with 2K certificates, and what happens if we go to 4K certificates? Because what the market is saying is that the performance penalty to go from 2K to 4K is 20 times the performance. So it would be cool to test that, and we would probably kill some stuff.
And he told me that a night before a presentation in Amsterdam, right?
Yeah.
So I didn't sleep that night. I need to generate a 4K certificate because I didn't have it at the time. And I started running the test and said, I mean, I honestly, I was thinking that, okay, we'll get a slightly different result, but well, it could be comparable to what we already see. So I said, okay, I'll work all night for nothing, and
but you didn't.
Yeah,
so.
but I didn't, as you'll see in a second.
So what happens on the G8?
G6. Sorry, G8.
Yeah,
sorry,
so
G8.
this is already the better performing CPU architecture. So what do you see right here is that we are maxing it out completely.
I mean, not only maxing it, as you can see, you can't even get even close to 1,000 SSL connections a second. Why? Because the vServer would go down, right? And then it would come up, and once it's up, well, in this case, you would see some serious latency here. 209, 124, 155, etc., 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 etc. So finally, after weeks of testing, we managed to kill a VPX, right? So I was really proud of our work.
Yeah.
I didn't spend a night working for nothing. And finally, I got really, really surprised. What is happening here is that you're seeing around 600 connections. This is basically the maximum that it will take. The system will go down, the vServer will go down, the CPU consumption basically would start to decrease. You'll start treating basically the transactions on the queue, and once the vServer would go up eventually, it would get killed by the server on the backend pushing additional load, right? So, okay, well, you can say it's extreme, 1,000 SSL sessions a second. This brings us to 3,600,000 sessions an hour. But definitely we have numbers confirming that with a 4K certificate, well, we see some serious difference in behavior compared to a 2K platform.
Yeah. So what is good to know is that the NetScaler is such an amazing platform, and it's amazingly stable, because the VPX would just die on us, so we couldn't do anything on it anymore. But when we stopped the test, it would just continue handling all those packets in the queue, and it came back to life. So we were not actually crashing it as you would have been doing on an IIS server. The VPX would just stop responding, and when we stopped the test and it got some CPU cycles again, it would just handle the packet queue again. So we didn't lose any packets. And that was really some
Absolutely
exciting stuff to see. That's something I wouldn't expect, because I'm a Windows guy. He would expect it because he's more of a NetScaler guy.
Basically, he would compensate his capacity to treat the traffic by basically pushing the latency up, right, and giving him time to treat the traffic, which is absolutely exceptional. So as you can see, we're pinging the box at the same time, just to show you, I mean, how it really looked like during the testing. And this is what you see. You would get from 209 back to 639, 5 milliseconds, right, and then the server on the backend would hammer it, and you will see again a spike in latency, and he will try to treat the queue as.
Yeah. So now that we can kill a VPX, it will be cool to see how the Cavium chips will handle these amounts of traffic.
Yeah.
So we started without Cavium on the SDX.
And you'll get to 95%. I mean, Cavium was performing beautifully. SDX without Cavium was performing beautifully. We're 95% CPU usage, right? With these numbers, even though they are extremely high, you don't see any impact on the latency level. Latency is stable. I mean, the box is being severely hit, but from the latency side, you wouldn't see any difference. And one more time, please remember that those numbers are there just for a few seconds, right? Once the initial handshake float has been treated by the device, right? You would see a completely standard, regular CPU load. So you would need a website or something managing to do persistent 1,000 SSL connections a second, basically to seriously challenge a VPX box with one vCPU, right, and 4 gigs of RAM, which is just exceptional.
So what happens if we go to Cavium now? Because we have some serious hits on performance on CPU. So what happens if we go to Cavium? You will see exactly
the same numbers.
Exactly the same as with 2K certificates. So it makes absolute sense to use Cavium. Especially when we will start growing to 4K certificates, which will happen in a couple of years from now.
And I mean, I thought I was too tired, right? Because it was right 4 a.m. when I came to that test. I said, no, I did something wrong. I took the wrong certificate, right? So I was checking it 7 times, and all right, everything was fine. The certificates were okay. I was looping that all the time, and I never went beyond 420. This is as high as I could go. Just amazing stuff.
And the fun thing about this is that we only use 2 Cavium cores. So we didn't use an entire Cavium chip, we only use 2 of the cores. It's like the least amount of cores you can assign to a VPX on an SDX box. So,
question, Barry, does the MVX series also have the Cavium cores?
Absolutely, absolutely the same thing. We use the SDX because basically what we want you to compare the VMs, right? How it would perform on the hypervisor, regular hypervisor you have probably in your environment, and on the hypervisor, right? Kind of custom hypervisor that Citrix is providing the SDX.
So the SDX is just
The question is, did you try it with SenServer as well?
Because you say you do it on VMware, because because this test will be like,
yeah.
let's say, but
So
this
Zen
is
server is on
great
the
stuff. We should try that. This is in a way a Zen server, but with SRIOV, it's a strict version, so you can't really call it a standard hypervisor, right? You're right, but with the standard Zen server, we will have a problem with an SDX, with the Cavium chips, right? You can't, I mean, technically you could build your own SDX, buying a Cavium silicon, put it in, etc., etc. But definitely we should do some Zen server testing, right? And on the other hand, it will be kind of difficult to match it. We will need to have the same hardware on both sides, right? On Zen server and SDX, and VMware. And as we use our production environment, yeah, it was kind of difficult to strip off the blades and install Zen server just for testing purposes.
So we will be getting our hands on some new hardware, and not new hardware, but at least dedicated hardware for testing. And I think one of the first tests we should do is have ESX on there with SRIOV-like technology, so we have direct access to the network card. Because of the statement we made earlier, which was a bit of a tease, that where I said Zen server is better than VMware. But VMware is not SRIOV, what we tested. So to be really honest, we should do SRIOV to make sure.
Yeah, but this will be extremely complicated because we would need to modify the VMware VPX instance, because the Citrix doesn't have an intention on providing drivers on the VPX platform, right?
I think according to EULA, we are not even allowed to change anything in the code on the NetScaler.
Yeah.
So that would make it a bit hard to present on it here.
Have you thought about using MPX hardware and installing Zen server on it?
Well, basically this is what it is. 11,500 box is technically can be used as a standard MPX. It would be an MPX 11,500,
no,
right?
Just using as a usual piece of hardware. So starting with a blank.
You can't do that. So if you have an MPX, you can upgrade it to an SDX. So you buy a new license, and then you get a new SSD. So you're not able to just install something on an MPX.
Yes, but that's a challenge. For your test, it would be great because you're using the same hardware as Citrix does. So if you can manage to preload this SSD with something that can boot, so maybe you can DD a fully installed drive on it.
What we can do, but we would technically kill the SDX, and I did that, right? I installed a Zen server, a regular Zen server on top of SDX, so I lost the possibility to see my Cavium chips. I was basically running a €100,000 Zen server, right, on it. And luckily the Citrix gave me a spare disk, so I could get back to a regular SDX platform. I crashed the disk and changed the stuff. So I mean, doing that, I mean, if we do that, we will need to find a way to have this spare disk somewhere rapidly. In this case, yes, we could run it on a Zen server. I don't think we could install technically on VMware.
And I think the stuff we are looking at is about SSL performance in general. So we are NetScaler guys, so we used the NetScaler to do tests with SSL. But in the end, it's not about Zen server or VMware or NetScaler or F5. It's about SSL.
And about NetScaler, because I mean, whatever the hypervisor you're using, right? I don't have anything against VMware. We were just joking, right? VMware performed incredibly well. I mean, with all generation CPUs, we went up to 80-something%, which is just nothing. This is just a spike, few seconds spike, and then getting back to a regular 2, 3, 4, 5% CPU, depending on traffic type, right?
So after all the testing, what we have seen is that it makes sense to buy newer architecture CPUs. I mean, it makes, I think we saw like almost 20% of a performance difference on the newer type of CPU with a lower clock speed than the older type. So that was quite cool to see.
Absolutely.
The Cavium impact, I mean, there's no question about Cavium makes sense for SSL offloading. I mean, it's the only reason why they built Cavium, the Cavium offload chips. That's especially made for SSL, and it makes absolute sense to use Cavium. The SSL bit size impact, so the stories they tell you about, you need 5 times the performance if you go from 1K to 2K, and 20 times the performance if you go from 2K to 4K. I don't know exactly if it's like 20 times, but we do see a massive difference in performance you would need. On the hypervisor node, yeah, we talked about that, and especially for Claudio, I will repeat it again. Zen server is better than VMware.
Yeah, fact.
So after the conclusion, these are just some of the things we noticed during the testing, and we were intrigued by, and we tested some more on it. So one of the things we said we can honestly say is a NetScaler VPX does not scale. So this got a couple of people at Citrix
really pissed off.
Really pissed off at us. So what we have done is what I said to Julian is hey, we do the 4K test and we maximize the CPU load. So I will just add CPUs. I mean, it's a virtual platform. I will add a CPU, and then we would only have 50% of CPU load. So we added the CPU, and we reran the test, and it was still 100%. And we were like, this is strange. So we booted the VPX again and watched all the startup scripts running, and we saw that only one packet engine was started. So we dug into the documentation, and we couldn't find anything on it.
You could explain why adding, for example, 4 vCPUs will just. I mean, what is crazy is your FreeBSD would see those CPUs, right? On the bare metal level, you would see those CPUs, but NetScaler will just take one and say, oh, I'm scheduling on the CPU 0. I'm cool with it, and we didn't have an explanation for that. And
so in that way, a VPX does not scale. If you're out of CPU resources, you're done. So we have talked about NetScaler, we have talked about AG. But as I said before, this presentation is about SSL. So if you have a random SharePoint server, or you have a random webmail server, or whatever application that uses SSL,
I mean, in our opinion, when we were testing that, we were saying, well, at one point you won't scale anymore, and this is really a shame, right? Because just adding additional CPUs would help you out, running on your VPXs happily, etc., etc. But
yeah, so if I have a webmail server, I have like 4 or 5 devices synchronizing my Exchange mailbox to the device. So if I have 500 users that have 5 devices, I have 2,500 users connecting to a webmail server and getting the data out. So you will need extra resources to handle the SSL traffic on that box. So from what we have shown you here in all these tests, think about the web application. It's not only about NetScaler. You will see the same performance hit on a Windows server with the same CPUs running an SSL certificate. So think about that. So after our first presentation on the Dutch Citrix user group in March, we already told Citrix was kind of pissed, and they actually wrote a support article. So 2 weeks after our first presentation, they wrote a support article. I just found it on Wednesday when I was rechecking all the facts. And they say a NetScaler does scale, but you are doing it wrong. And they were true. That was true. So what they are saying now is that a packet engine consists not only of a vCPU, but also a bit of memory. So it will never start another packet engine if you only add CPU. You would also need to add memory. The thing is, they on all the data sheets, they never tell you anything about packet engines.
And they never tell you anything about the license requirement to run it, because in my production environment, I had a VPX 200, so I could add up to 60 gigs of RAM. That wouldn't change absolutely anything. CPU or memory, whatever you wanted, Well, you're on VPX 200 level. Well, you're stuck with one vCPU engine, which is kind of crazy because depending on the traffic, I've seen, for example, a 2,500 concurrent CCUs would take around 5 to 60% of CPU and 25 to 30 megs of RAM. I mean, Xenop workloads with all the things you already know, right?
So if you look at this support article, you would see that it was written 2 or 3 weeks after our first presentation. What you're seeing here is that if you have VPX 200, you will only get one packet engine, so it wouldn't scale that good. But if you have a VPX 1000, you are able to get up to 3 packet engines as long as you add the required memory. If you go to a 3000, you get also 3 packet engines. If you go up to an 8000, and has anyone ever seen an 8000 on a list somewhere?
What is that?
8000 would be, this would be the bandwidth the machine can take. 10 megs, 200 megs, a gig, 3 gig, 8 gig.
I
8
mean,
gig VPX.
An 8 gig VPX, I mean, that's more than the hardware. So the MPX 8005 can only do 5 gigabits. I mean, this is 8 gigabits on a virtual platform. You can't buy it. I don't know, there's some kind of a special customer in the US that uses it, but there you can start 5 packet engines. The only thing you should think about is that, I mean, the license is quite expensive. If you go up to a VPX 1000, the license will be somewhere around $11,000 list price, and a MPX model that would handle a gigabit of traffic only costs like $15,000 list price.
So basically the VM is as expensive as a physical hardware, and which is really great because 2 or 3 years ago, the official position, I mean the Citrix, I mean luckily for us, for the community changed since well, the VPX simply don't scale. You use it for a test environment, etc., etc. Providing this type of appliances, even though the prices are extremely high, proves that basically choosing a VPX or NPX, SDX, whatever, is just a use case stuff. If you are confident enough in your virtual infrastructure, make sure that your hypervisor can provide you with the throughput they have here without any problem, and there is no, I mean, the regular stuff that are valid with the Xenop workloads in a way. I mean, you wouldn't want your VPX waiting for CPU. I mean, simply it will perform bad. As long as the hypervisor, underlying hypervisor can provide resources, you wouldn't see any difference in behavior except the part with SSL uploading, of course, between a VPX and our NPX.
So one thing to remember here is that the NetScaler will always start dedicating the first CPU for system administration, for simple tasks. So if you want 3 packet engines, you would need 4 virtual CPUs. So remember that if you want more packet engines.
Yeah, don't be surprised allocating 4 and then seeing 3, and in a GUI, if you're a GUI guy, well, you will see just, I mean, basically you'll, in a graph, right, we presented a few minutes ago, you'll see just 1. You won't see 3 of them. So you will try to take this in a global way, calculate the level.
So what's next? I think after we did the presentation at the user group, we are quite convinced that there's more to test, and that the community is interested in seeing more. And one of the questions we now have, and we haven't done any work on it yet, is if all the hackers are using GPUs to decrypt encrypted data, would it make sense to use it for like legal stuff? I mean, if it's good at illegally cracking encrypted data, why wouldn't it be good at encrypting data? So that's a question we have now. We don't have the answers yet, but it's kind of a teaser for our next presentation.
Yeah,
hopefully.
we're working with NVIDIA at the moment. We're in discussion with them. So we'll see how, I hope for the next presentation, maybe next E3, we'll have some, well, interesting numbers on how the GPU might perform. We do believe, and I don't know if this means a lot because I was wrong at least tens of times during this presentation, but I really do believe that the GPU should really perform good in this type of
I think this will be quite impressive.
Actually, it's same arithmetic operation which GPUs do. I saw there are PDFs on topic.
Yeah.
How to use GPS to crypt SSL with commodity hardware. I think you will find.
There's already someone. I think it's a master thesis for a university in the US from a couple of years ago that already did some work on it. But those were the GPUs of like 5 or 6 years ago. So with the architecture changes now on GPUs, I think it will be. This will be exciting stuff. Well,
but you do this, I forgot the name, this transformations, that's what you do. So that's what the graphic card do 5 years ago and now.
Yeah, absolutely. It's a mathematical coprocessor. I 100% agree with you. And the only problem I see there, which could be kind of problematic during the testing, is the quality of the drivers.
Yes.
Right. So what we're going to do, we'll probably go into the Linux platform, so we could, with help of NVIDIA, of course, maybe recompile and modify the drivers to adapt it to this type of workload. So there's plenty of work.
so we need Remco.
Yeah, and we'll definitely Remco if he's wake up.
He isn't awake. Neil is, but
I mean,
Remco
I
went on
almost
for a
missed my
while.
session today, so I mean, I understand Remco completely.
Any other questions? No? Don't worry.
So Barry, what's your recommendation? So do we try and scale a single VPX, or do we try and use multiple VPXs for a customer?
It depends.
Depends on your traffic. You know, I hate to say that, but it depends on your use case. If you're doing a regular XenApp stuff, right? You are basically doing ICA proxy, etc., etc. There are two things that needs to be taken into consideration. The CPU will be the CPUs will be fairly the same, right? Because maintaining those SSL connections between your clients and your NetScaler simply is not taking resources. In my production environment, I was observing a 1% hit for every 500 connected users, right? So this is something you can use as a baseline. And then the problem would be a bandwidth. I mean, the XenApp or Xen Desktop wouldn't kind of take the same amount of bandwidth from the NetScaler. So if you would be running on a VPX 200 box, well, you might come in a situation where you'll be limited in bandwidth. So I would advise for this type of workload, maybe a VPX 1000. Well, just to make sure that you have enough bandwidth to serve those users.
And for at least 50% of the customers I walk into, it's a question about, can we virtualize in your DMZ? I mean,
this is
for
also
50% of my customers, the answer is already there and they say no. And the others say yes, and then it's a question about do you need performance.
Yeah, there is absolutely no problem of using it in production, really.
Yeah, I think bandwidth and the fact that the security officer allows you to virtualize in DMZ is one thing, but the other thing is, I think if you implement the NetScaler as it's meant to be, as a multi-purpose networking appliance, and you also doing load balancing, remote access, are you willing to rely on the availability on your hypervisor? Because
That's
if
a
you
good one.
implement it as the heart of your network infrastructure,
I agree.
and the shit hits the fan, do you want to rely on your underlying hypervisor, or do you want NetScaler?
Basically, I'll share with you my production experience with that. I was running an HA, of course, it was a single instance, right? And I was running HA across data centers. Okay, we had a pretty good interconnected data centers, right? It was not Europe, Asia, or something like that. But basically, in the case of a failure, I would fail over seamlessly to another data center, right? So this could be a use case. The other use case could be a HAGSLB stuff, where you can do an active. I mean, the same rules apply with your VPX that they would with your MPX, and then the probability that your underlying hypervisor infrastructure is bad would not only impact your NetScaler users. I mean, it would be a global problem.
Customer of me solves that question in a very interesting way. He he acquired he is using 2 VPX, but one on the VMware infrastructure with the just normal thing, and the second one with the Zen server with local storage. So it's just a box over somewhere in the network, no dependencies, no Zen, no other things, and it's a different technology
I
stack.
agree, but in this case your customer is basically doing an NPX without an SSL offloading, right?
You're dedicating
So
the box.
the advantage
There are
of
pros and
using
cons.
VPX is kind of to put it on a mutualized platform, and then in this case you'll be really cost effective. A VPX 200 standard license is something around 2,000 euros.
And I think it's not
This is
supported.
really cheap.
It's a non-supported setup because you're doing different architecture underneath, and you're doing HA. So if HA breaks, don't call Citrix because they say same boxes, same versions, same everything. So I don't think that this will be a supported setup. And one of the things, and then you can go gladly, is that we are talking only about SSL performance, but that's only a small part of the CPU resource usage. If you're doing compression on your packets and stuff, you would use more CPU cycles as well.
Absolutely.
So this is only about SSL, but there's much more you can do.
If you're doing application firewalling, for example, well, in this case, your CPU, additional CPUs, and offloading of those of the SSL traffic would come into really handy.
So I think we have time for one question. Otherwise, we'll make time. Always make time for Claudio.
Just one thing, like I always think about cost at the end of the day.
Yeah.
And you saw, well, you showed the top VPX, but you didn't show the tests on a top VPX. What the numbers would be if I'm running the biggest one that I can.
Yeah.
Because at the end of the day, what would be more cost effective? If I buy an SDX at 100,000 euro, but I buy the top VPX at 8,000, because for me it doesn't matter like what the CPU usage is. What I guess you care as well is what the latency is at the end of the day.
Yeah.
Yeah.
If it's I'm 99, but the latency doesn't change, I don't give a shit.
This is
But
exactly
the
what we saw,
8,000,
Yeah.
the 8,000 model will
day,
cost you $50,000
yeah,
less.
what would be the cost if I run the biggest VPX and my latency is the same as the SDX? What are we talking about? 2, 3, 4 times more cost on
Yeah,
the
but
SDX?
you have the cost of the license.
Oh, I understand.
But you would still need to reserve the resources on your hypervisor platform
I
as well.
understand, but if I add
You will be more cost
everything,
effective on
how
the
they compare?
VPX.
No?
Definitely, I think you will be more cost effective. There is no doubt about that.
But how much more?
How
We're
much
talking
more? I
about
think it depends on the
50% more?
workloads. I mean, the guys who would really use symmetrically 8 gigs of bandwidth are serious guys, right?
But you can't do that. If you buy an 8 gigabit VPX, you can't do 8 gigabit of SSL data. You can only do 1 gigabit of SSL data. That's the thing with all those numbers from F5 and NetScaler. The top numbers will always be HTTP, non-compressed, non-load balanced, just pack it in, pack it out. So if you go do SSL, it will only do 1 gigabit of SSL.
But for regular scenarios, right? Because one more time, the thing we tested is extreme, right? This is 1,000 handshakes a second. I mean, who does that? I don't think Amazon does something. I mean, maybe during sales, and not for. I mean, not constantly. So I think for the regular scenarios, VPX, provided that you're okay with security teams, you're confident in your virtualization skills, is definitely a way to go for plenty of use case scenarios. And among those, right, a standard load balancing of whatever traffic you get on the back end, probably XenApp Zen Desktop are really good use cases for it.
We're way over time now, so if there are any questions, please come to us, we will answer them. But we're way over time and we started too late, so thank you all for being here.